Hello, welcome to another vulnerability. Today we're going to be talking about a service actually, SSH. So SSH is a service on Linux machines that's typically used to access that machine remotely. So here I have my server that I'm running. I'm going to run systemctl status SSH. And so you can see that my SSH server is running, which is great. So now I want to connect to this on my local machine. So in order to do that, I need to know the IP of this machine. So if I do IPA, I get the IP is right here, this one. So I want to SSH into this, and I know what user I want to SSH in as. I want to SSH in as Pukey. So let's go ahead and do that. So I'm going to, actually, let's not do Pukey. Let's do Bill. Bill is just a random user that I made. So let's do that. So I want to SSH as Bill at this IP, so 172.16.208.128. And that's it. I run that command, it asks me for a password, I enter it, and it worked. I'm now in. So if I ask my ID, I am Bill. And on what machine am I? I am that VMware, my server over here. And so basically now I can just do things as you normally would directly on your machine. So that is the beauty of SSH. And as you can see, it required a password, but it doesn't have to. You can actually use something else known as keys. And so in order to understand how keys work, first I need to explain quickly what public key cryptography is. So the idea behind SSH is we want it to be secure. All of our communications are encrypted, including the authentication. So one way that we can authenticate is by using cryptography. The idea behind public key cryptography is that we have something known as a trapdoor function. And the idea is that when we have plain text, we want to make it easy to encrypt, but hard to decrypt, unless you're your targeted recipient. So in this sort of scenario, what we would have is you are the recipient here, and you want to communicate with someone out on the internet. All of your communications can be seen by anyone online, but you want to make it so that only you receive the information from the sender. No one else is able to figure out what that information is. So the original communication is known as the plain text data, and after we encrypt it, it becomes the ciphertext data. And the idea behind public key cryptography is, how do we do this? Well, we create a special function known as a trapdoor function, where it's very easy to encrypt data, but incredibly difficult to decrypt data. This trapdoor function only goes one way. It only allows you to encrypt, not to decrypt. So the idea is the recipient utilizes this. It's going to tell everyone, hey, here is my public key. You can use this to encrypt your communications. And if you encrypt it using this, then I'm the only one who can decrypt it, because I have a special private key that goes with it. And normally, it's really hard to decrypt. But with this private key, you have some insider info that makes it really easy to decrypt. And so this is the idea behind public key cryptography. We have both a private key that we hold on to so that we can decrypt the communications, and we have a public key that we give out to everyone so that they can encrypt the communications. And so let's take that down to SSH. So for SSH, we can use these keys to authenticate, which eliminates the need for a password, because since only we have access to the private key, only we can make sense of the communications. So just by being able to communicate with this key, we're able to prove our identity. So how it works, this is the whole process for what we would do. Let's say that we have a server representing the middle, and this server has two users, Bob and Cal. Meanwhile, we have two remote people that are not on the server. They're on their own machines, and they want to be able to SSH into this server. So what each of them is going to do, for example, let's start with this user on the left. He is going to use a command called SSH Keygen to generate his keys, his private key and his public key. He's going to take that public key and he's going to give it to the server. The server is going to store that key in a specific file, specifically for the user that we want to be able to authenticate as, the user that we want to SSH into. And so what he's going to do is this key, this public key, is now inside a special file for that user, specifically this .ssh authorized keys file. This is a file that contains all of the public keys of people that should be allowed to SSH in. So he does that for Bob. And now, whenever this user wants to SSH into Bob, they can just do it because they have the private key. It works out for them, okay? But he's not limited to just one user. Let's say that he wanted to also be able to SSH into Cal. He just repeats the process. SSH keygen to make the keys, gives Cal the public key in his authorized keys folder. And so now this user can authenticate to either of them using this private key. And since only he has the private key, only he can SSH into these users using that authorized key. The cool thing about this is that multiple users can do this at the same time. So if this user over here on the right also wants to be able to SSH in using the key, just needs to do SSH keygen to generate the keys, then gives the private key to Cal on that SSH server. And now both of these users are able to SSH into here because both of them have their public keys and authorized keys. Hopefully that made sense. This is the idea behind how SSH key authentication works. You're going to notice that it's pretty important that one, this private key stays private to whoever's trying to get in. And two, the public keys are in this authorized keys folder. So, as red team, if we're able to put our public key in here, then we can SSH into a user on that machine anytime we want without worrying about having the right password. So even if they change passwords, if this key stays here, we can still get it. And that's exactly what we're going to do. So here's just very explicitly the steps. First, you're going to run SSH keygen. That's going to give you two things. It's going to give you your private key, the ID RSA, and a public key, the ID RSA.pub. Give this public key and put it in that authorized keys file for the user you want. Okay? Then we have to also make sure that SSH is configured to allow for this key authentication. It is allowed by default, but maybe the sysadmin disabled it because they know it can be exploited. So in this case, we want to ensure that this config file, the SSH daemon config, has the line pub key authentication yes in it. If it does, then this method is allowed. So if we do these two things, one, make sure the config file is good, and two, make sure they have our key, our public key, inside authorized keys, then we're able to SSH in using a key whenever we want. And that's awesome. Gives us unlimited access to the system. So as Blue Team, how do we defend this? It's pretty simple. The public key is stored in authorized keys. So we just need to check everyone's authorized keys file to make sure they don't have any sus keys in there. A very simple way, if you just want to stop all keys, is you can rename this file to anything else. For example, unauthorized keys. And then it just stops working because there no longer exists this file. It's been moved somewhere else. So that's one way to secure it. Another thing is you should change the config to say pub key authentication no, in the case that you do not want any public key authentication. Sometimes in a competition like CCDC, you are supposed to have SSH key authentication, specifically like for some black team agent. In that case, you can't do this because then that prevents the allowed user from being able to log in through the allowed method. Instead, you have to check their authorized keys to make sure they only have legitimate ones. And that is basically all there is to SSH. So with that being said, we can test out this SSH key vulnerability. And to do that, let me just log in. And let's clear. Okay, I want to pick the SSH key module. Okay, and if I look at my current set, yep, I have it. So let's go ahead and set this up. Cool, looks like it worked. And let's check. Boom, we have one vulnerability we have not touched yet. So to do this, we would need to look through everyone's authorized keys to see if it's enabled. First of all, let's go ahead and check that SSH config. And let's look for, what was it? It was pub key authentication. Let's look for pub key authentication. Okay, pub key authentication is yes. That is not good if we're blue team, or maybe it needs to be. If we want to stop all pub key authentication, we could go ahead and change this to no. Okay. And if you saw in the description, it said that users should only be logging in through password. So this is totally legitimate, and we could save these changes. So I could do that, and we could keep on going. However, we still need to check if anyone has an authorized key just to be safe. So let's go ahead and let's enumerate our users again. So we enumerate our users, and this last field, this last column here, that shows who has the keys, the authorized keys file. And we'll see here that in here, we have two users have authorized keys. In this case, Pukey, which I'm going to ignore for now, and Jolene. Jolene has an authorized key as well as a home directory, so let's go investigate that. So I'm going to go to home Jolene .ssh, and you'll see this authorized keys folder. They should not have this. So this is basically saying that we are using RSA encryption. Here is my key. And at the very end, this is who I am. I am Pukey at PopOS trying to log in. And that's just the syntax for this keys. They could change what this is, but this key is going to stay the same. So this, I think, is malicious because our config didn't say that anyone should be allowed to log in through SSH keys. So one thing I could do is I could just remove it completely. That would work. Or if I want to be safer, I could rename it to something cheeky like unauthorized keys. And that would work. So now if I go to BlueDaBaDee again, home Pukey, BlueDaBaDee, Linux, and I run my checker again, hey, it's been patched. We fixed the authorized keys. And so that is the vulnerability there. So once again, thank you for watching, and I'll see you in the next one. Bye-bye.